Happy Thursday before Spirit Day. It's like a Friday. Right?
Yeah.
So much muttering goes on in this class. Hopefully it's productive. If you guys see your points, graph your points and then just connect with this whoopie scoop. So the last point needs to be hollow because it's on the hole. And we've talked about domain before. We've talked about range before. We've talked about domain before. We've talked about range before. And just in case function notation is still a little weird to you, can someone just help us all out real quick and say what kind of values are we looking for as our answers to these? We're looking for y's, and f of x, we're given x's. Okay, once you have it sketched, I want you in groups to discuss and get me 4 different answers. These two should be numbers. These two should be ranges, intervals, inequalities, perhaps. Ready, set, go. Have your sketch, talk it out. Turn it, twist and collaborate.
Inequality.
Graph the points first.
The x values it's like so it's between this point and this point right here. So this point's -1.
Let's not record our swirliness. Okay, group number 3. What's the domain of f?
X is greater than or equal to 0 and x is less than or equal to 5.
Okay. They put forth an answer. Is there a group, the spokesperson only, please? The only spokesperson raise their hand. Is there a group that wants to counter that? Ricky?
I think it's -1.
Okay.
And the 5 is not equal to 5. It's just less than.
So quick correction. All right, back to group number 3. Does it make sense why -1? Because you can go a little bit back from 0, and then y not or equal to, because it's a whole. Does that make sense? Now, group number 1. How would you write it in intervals?
It would be a bracket,
Okay.
a -1,
Okay.
and then a 5 with a
Good. But what separates?
comma.
And I'm going to add one little. David, what's your question? You're good? Oh. Yeah. Other questions? Groups out there? Does anybody have a totally different answer and you're like, what's going on? Okay, letter B. I'm going to look for both answers at once. I've used group number 1, I've used group number 3, and group number 8. Let's go group number 5. F of -1. What'd you guys get?
Oh, we're group 5.
Oh, I keep on
They're
messing
group
that up.
8.
Yeah, I messed you guys up. Go ahead.
Oh,
I already did 5. 8.
Yeah. We did.
Oh. 7.
Well, we got range.
All right.
Oh, wow.
Hey, that's good though. All right, JJ, what's range?
Bracket 1, comma 2, parentheses. No, restart.
It'd be y within, which would be the same thing as, I'm just reading their interval. Okay. Group number 6. Do you have a correction you want to make?
Yeah, it's actually bracket 3, comma -3 bracket.
Oh, wait.
Is that what it is? Okay, now hold on. Let me double check. I agree. Group number 7, because it makes sense. How low can you go? -3. Right? How high can you go? 3. Now, what question? JJ, go ahead. Sorry. For range, we can always think, remember, tick marks on the y-axis, and tick marks on the y-axis go up and down. So we're literally asking the range of y values, how low, what's the lowest y value? What's the highest y value? What question could be given, or what statement could be given to remind us of how domain works? If range is how low to how high, domain would be how far left to how far right. And why left before right? Because left is the lower, which comes first. Right is the higher, which comes second. Why down to up? Down is the lower, which comes first. Up is the higher, which comes second. All right. We've done almost all the groups besides, I believe, group number 4 and 2. So we'll ask each of you one. Group number 2, what is f of negative 1?
It's 1.
Are you sure?
Yes.
How'd you know it, Nathan?
Because the point negative 1, 1 in your
No.
If this is an x value, find x is negative 1, go find the y. Bingo. And group number 4, who's my spokesperson? What's f of 2?
It's negative 2.
Almost.
2. Negative 3.
Why negative 3?
Because if you multiply.
No.
Hold on, group number 4. There's 4 of you. Help each other out. Poor Blake. He's just like out there on his own.
Because you add.
If x is 2,
Oh, you add 1, 2.
go to 2. Who is his y value? You see it?
Yeah.
Now guys, hold on. This is really tricky for some, especially if they haven't had a strong foundation in function notation. Because remember what this is saying. Find the y value of the function, which is the graph. Find the y value of him when x is 2. How do you find the y value? We'll figure out the point. Go to 2. Figure out the y. Done, done, done. Guess what? Notes today, still in section 1.5, start right here. Hey, you just did it. Notes open. Notes open. And if you guys were like, that was easy, good, it was kind of review. And if you were like, that was hard, you did the example before the notes, so there you go. You can look at it both ways. Notes open. And let's focus on it. Focus on it. And if you guys notice, what you kind of pulled out from what we talked about in our example, for domain, we are asking the question, how far left, how far right. In range, how far, I don't like that order. What am I going to switch it to be? Down comes first in intervals, right? And then comes up. Now it's kind of different than we normally say it. We say up and down. But, are you good? No. Anyway. The proper way for interval notation is down, then up. How far down, and then how far up. You're like, why are we covering this again? Number 1, to put these questions in, because I think they are helpful. And number 2, for interval notation, to remember. Now, I'm not going to put brackets or parentheses because it depends, right? Whether it's closed or whether it's open, meaning the point. But I am going to say left, comma, right, right? How far left, how far right? With brackets or parentheses depends on the situation. How far down and up? Down. Then up. Brackets or parentheses, it depends on the situation, right? I'll give you a couple seconds. Is this a fairly good recap of the example? Yes, for everything but those funny f of negative 2, no, f of negative 1, f of 2 things. Let's remind ourselves real quick. Y values can also be called f of x values. How come? Because who is f of x? The function of y's, right? The y's of the function. And as soon as we put a number in there, f of 1, we're establishing when x is 1, and that's an algebra 1-ish question. When x is 1, go find it. Plug it in, or go to the graph. Plug it in, go to the graph. Couple more seconds, we should be close. Alright, if you guys remember 1.5, I think this title is like analyzing functions, analyzing graphs of functions. There we go. So something else that we need to talk about with graphs of functions, the zeros. But wait a minute. Do you see something familiar on this page? X-intercepts, we've already talked about those. What? Your turn. The zeros of a function, think like function notation, we have a few things to kind of still work out. The zeros of a function are the x-intercepts. Just another term. The zeros of the function are the x-intercepts, not the y. The x-intercepts. And if you guys remember from before, I'll put it in green because it's kind of reviewish. I usually try to keep green to be mostly review concepts. Didn't we set y equal to 0? Why does this mean the same thing? F of x is 1, right? Just trying to keep on cementing that into your brain, into your memory. F of x does not mean f times x. It means the y values when x is. If they don't put something there, for all the different x values, and if they put a number there, for a specific one. Now, if we set y equal to 0, I have an example on the next page. I just need you guys to help me out. There's actually one more word I want to write before we do the next example. So look at the example and try to think of, if I'm trying to give you hints, finding the zeros, the x-intercepts at y equal to 0, what is one thing, if possible, I want you to do every time with these types of problems?
Right now, your work or something.
Specific workshop. I heard it louder. Factor. Factor, 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 factor. Don't start moving stuff around. Some of you, at times, are your own worst mathematical nightmare. It's true. Now, sometimes the problems are, I understand. Sometimes the teacher is, we'll see. But sometimes you're your own worst nightmare. At least as far as getting points. Because if you don't factor, you won't get all the answers. So, find the zeros, otherwise known as find the x-intercepts. The solving clue is set. And some of you, wait, pencils down, pencils down, pencils down. One of the most common mistakes I see that throws you off for the entire problem. Like not even just I'm bad at factoring, but just you don't remember what you're supposed to do. Is those few of you, and you know who you are, that do this first. If you don't like it, you're like, add the 10, and then we get to do some like magic stuff, and the magic stuff means like do this, and then we have like a this, and then it's like, oh hey, let's set each equal to 10. Is that legal factoring? You can only factor and set factors equal to only one number, and that one number is what? You have to have something. You cannot remove the 0, you cannot change the 0, you cannot put numbers over by the 0. It must remain 0, and you have to do the hard work of figuring out the factors on the side. Now, real quick, just with a raise of hands, how many of you see a factor problem like that? And you immediately think of like this big old X that you plug numbers in, top, bottom, right, left. Okay, a couple. How many of you guys look at a problem like this, and you immediately think of a box that you fill in numbers? No. How do you guys think of Mr. Crawford? I need to split this X term into 2 separate X terms that make it, and then do some grouping stuff. Okay? How many of you guys go straight to an answer and try guessing and checking with all the different possible ways of figuring out how you can get 3x squared and all the different possible ways that you can get 10. And you just start playing around. Okay. The rest of you guys didn't raise your hand for anything. So hopefully, how many of you guys use quadratic formula every time? Okay, good. Whew, that's right. How many of you guys complete the square? Okay. Just saying. There's still quite a few, I'd say at least 1/3 of the class that are like, I don't have a way. My way is guess and check, but that's the way that's the hardest to explain to kids, and they just think it's super like long and frustrating, even though if you get really good at it, it's the fastest one. It's okay. Mr. Crawford, and I think Mr. Park did grouping. My Mr. Park people from last year. Let's see if we're right. Does anyone remember how to deal with a number in front? Because these are the ones you see. Multiply the outer together as long as they're in descending order. So 3 times negative 10, negative 30. And we ask ourselves, what are all the different possible factors of? Some of you are like, there are so many. There are, but be strategic. 1 goes into 30, 2 goes into 30, 3 goes into 30, 4 goes into 30, 5 goes into 30, And if you notice, 6 goes into 30, and we just go backwards. These are the only possible. And we ask ourselves the question, first of all, I haven't put negatives or positives in yet. But second of all, I need 2 of them to add to be 1. Nope, nope, nope. Do I need a positive one or a negative one? So if I need factors, and I need 1 positive, 1 negative, that 6 better be a positive, and that 5 better be a negative. True? Okay, now what do we do with those 2 numbers? That's great now. But now what? Split up that middle term and say you came from 2 different ones. Negative 5, positive 6, but they're x terms because they had to make 1 x. Now who else is still there? 3x squared, and then the minus 10. This is the grouping method. How many of you guys are like, oh, I kind of remember and kind of do that sometimes? Okay, more hands. Factoring is important. If you don't know how to do it, it's going to plague you for the rest of this year. Not the entire year, but definitely at many different times. You're like, ugh, I wish I knew how to do it. Please come in this week, next week. Sit down with me. Let's figure out a way that works for you. We'll get a whiteboard. We'll just kind of play with problems, okay? JJ.
I switched it around 6x plus negative or minus 5x.
Still fine, as long as you legally simplify. Still fine, as long as you legally simplify. Let me go ahead and switch it around too, just because there's a mistake that can happen super easily if you do switch it around. There's a mistake that can happen. First of all, we group. So we look at the first 2, look at the second 2, right? What's in common for the first 2?
3x.
3x. Pull them out. What's in common for the next one? Yeah, you could definitely kill a seal. Hold on. 5 is not the only thing in common. There's a negative in common too. Pull out the subtraction or the negative with it, which becomes a subtraction. And what do we get inside? And then my people that like grouping, what's your final step? Pull out the 3x and the 5 away from the common factor of x plus 2. Now, sadly, that was great work, but we have one more step before we're done. Whenever we have or need to find zeros, we take, first of all, we factor. Make sure that everything is being multiplied. And then we say, well, the only way to get 0 from a multiplication is one of them has to be. So find both. Both we do it. Showing the work. So at this point, guys, I'm going home. Here we go. Move stuff around. Use algebra, right? Technically, algebra is what lets us move to the other side. That's why I keep saying that. But it is pretty simple math here. How many zeros? 2. How many x-intercepts? 2. What kind of, I know we haven't really covered it yet, but maybe remember, what kind of graph is a quadratic? And it's positive, so it's up. So it's hitting the x-axis, something like this. And where is it hitting the x-axis? At -2 and at 1 2/3-ish. Hey, -2 and 1 2/3-ish. Nice. Okay. Graph analysis, concept number next one. I have no idea which one we're on, so we'll just say number.
Why do you say number next one?
I didn't keep track of all the things we've written in our notes. Could just say the next one, but that's no fun. And you know, like some of those exercises where it has like A, B, C, D? really confusing as a math teacher to be like, number B, so I just say number next one, then I never get in trouble. If that makes sense. So when you say number B, everyone starts laughing. How do we read English? What direction? How should you read English? Left to right. True? Thank you. English goes left to right. So then look at those different branches of the graph. Does it make sense? If we're going left to right, why it's decreasing, then constant, then increasing? You think of a little car that's on the graph. And if he's going left to right, he's going to be falling with the heights, stay at the same height, and then increasing with the heights, right? It's pretty self-explanatory. However, this idea can get kind of confusing. You're like, how? Well, just wait, I'll show you. But first of all, before we even get to how it can be confusing to even be able to write the words on the branches, the different parts of the graph that have different behaviors, we need to be able to explain, like an answer form with intervals, exactly where or for what x values the graph is decreasing, constant, and increasing. Okay? So we're going to describe them with hold on, just a second ago, when we were talking about domain, those are x values. When we were talking about domain, what was the question that we were trying to ask ourselves? How far left to how far right? The struggle that some of you guys are going to have on this part is that you're going to think y values when you should be thinking x values. You're going to think the actual numbers of how high, how low, instead of thinking how left, how right. Let me demonstrate for you, okay? If we were to, I'm just putting it over here to have more room. Maybe you guys should put it over there so it's not in our nice little key concept column. But how would we describe where the graph is decreasing, where the graph is constant, and where the graph is increasing? X intervals. X intervals, X intervals. This is the procedure. This is the strategy. This is the answer to describing where this graph is decreasing, constant, and increasing. So, you see the decreasing portion. My question, how far left does that portion go, and how far right does that portion go? First of all, no open circles, so I know it's going to be all brackets. And this thing doesn't go to infinity, so no parentheses. All right, who can figure out how far left the decreasing part goes? -2. Yeah, put that -1 from right here. -2, right? So -2 is how far left. Remember, we're looking at the x values. And how far right does it go?
It goes to 4.
Right? Yeah, I know. It's so easy. We start looking at the y values. You've got to look at the x's. So how far left? -2. How far right? 0. And some of you are like, psh, I wouldn't do that. Just wait for homework. You will. Possibly. Probably. Most likely. Okay, the constant portion. What's the far left x value of that portion of the graph? 0. Right? 0. How far right does it go? 2. See? We're not going to the y's, we're going to the x's. Last portion. How far left does it go? 2. How far right does it go? Does that make sense? So whenever we're describing or answering or interpreting increasing, decreasing, constant, we're answering with how far left to how far right for each of the different portions. One quick note before we go into examples on the next page. In order to be constant, now this is actually a calculus idea. I can't explain it fully to you without confusing you or making you really frustrated. So, in order to be constant, there needs to be passage of time or a length of x's that are flat. Okay? You'll see why I'm saying this in a second. But in order to be constant, there has to be an actual length of an interval Length of a graph that is flat, okay? Next page. Where's my constant? Huh. For each of the different graphs, I want you guys to answer the questions. And once again, for sake of time, because this is a somewhat beast of the section. There's a lot going on. We're going to work on it all together. Take a second to write down directions. Where is each graph? The graph of each of the different examples. Where are each of them increasing, decreasing, constant, if it applies? If it applies. If it applies. Get zoomed in a bit for you. Give you a second to get those sketches. And as you sketch, if I were you, the easy part, hopefully, is labeling the pieces of the graph. You don't have to do like the entire word increasing, the entire word decreasing, the entire word constant. But just label it with like I or C or D or I and C and DEC or CONST. Most of you guys are probably sketching the first one. What have you labeled it with so far? Increasing. Then what? This is the exception, this is the weird one. Some of you are like, but it's constant. Oh. If I zoom in, zoom in, zoom in, zoom in, like zoom right here, guess what it's still doing? Going up a little bit? It does level out for literally 1 point, and then it goes up some more. Very, very slowly, by very, very small increments. By a very, very flat slope. That's what I was trying to say. But it still technically is increasing all the way to there and increasing all the way to there. So when I said in order to be constant, it has to have a length. If it's only constant at a point, does it count? No. So no constant on that one. What'd you guys label the next one as? Hold on, we'll get back to intervals. Is it increasing? Yes. Now the tricky thing, when I said it might be tricky to figure out the increasing, decreasing, in just a second when we talk about intervals, some of you are going to think about this going to negative infinity, and you're like, oh, it's decreasing, but you're going the wrong way. So left to right, it's increasing, and then it's decreasing, and then it's, got it. Just think you don't ride a roller coaster backwards. Well, unless it's designed to do that. But anyway, you only ride it one direction, so you can only read these graphs one direction. A little like, click, 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 click up the hill is never like a shoo, right? No. Think about it. All right. How do we write them with intervals? How do we write them with intervals? What question are we asking again? Down and up or left and right? Left and right. How far left, how far right? So my question on this one, how far left, how far right? But what's the problem? There's no little closed circle, which means it's implied to be. So how far left? Negative. Why? It's negative forever, right? We can't say positive infinity, that's the other direction. Negative infinity to how far right?
Infinity. Positive infinity.
Yeah, but remember, if they don't put a closed circle, it means infinite. They just don't like writing the little arrows all the time. Which is okay, they don't have to. Now, to be completely honest, for those of you that might go on, the best way to actually write this one, remember how I said at 0, it's kind of his own little dude? He's constant, but since it's not a length, we don't really write him. Technically, this is the best way of writing it, because we kind of leave 0 out and say, don't talk about him. But, this will be fine for me, for you guys. Okay, next one. This was increasing, right? Okay. Where's the next one increasing? Negative infinity, remember, it keeps going. So it's going to keep going left. And as you go to a negative infinity, if you could get there, wouldn't it be increasing the whole time? So negative infinity, when does it stop? How far right? Negative 1. You can just separate with commas if there's more than one. This one there is. Where else is it increasing? How far left? 1. How far right? Infinity. Okay? Sorry, I was running out of room for the next example. Remember, how far left, how far right? Look at a branch and say, he keeps going. So negative infinity all the way to negative 1. And then 1 all the way to infinity. So where is it decreasing? Careful. How far left? Negative 1. How far right? 1. Don't look at the y's. Look at the x's. Train that brain.
Why are there not any brackets?
Good question. Could, at a point, at that point, could you be increasing and decreasing? No. Could you be just increasing or just decreasing? No. Here, actually, physics would teach us if this was a graph of motion, he would actually be momentarily stopped. Then, so we could leave him out altogether just by putting parentheses. Good question. Number last one. See, it wasn't number next one. Where is it increasing? Where is it decreasing? And if any place, which this one it is, where is it constant? Okay, increasing. What would you say? Negative infinity, because remember that's an implied. Keep going. Not 1. 0. Remember? Tick mark. I know it's hard. Negative infinity to 0. No judgment. Yeah, that's what I'm trying to instruct. Life lesson. Judge not lest you be judged. And then what?
0, 2.
How far left? 0. How far right? 2. I know it's hard. Oh, wrong one. Okay. I have a smart board. Okay. Decreasing. 2 to infinity. And beyond. Or isn't that infinity? Good question. Okay, we got it? Couple more seconds, just in case you're still waiting. 5, 4, 3, 2. Matthew? All right, we're almost there. This is technically, I would say, 2 more topics. One's just a formula, and one's just review. We can do that in 5 minutes. One's just a formula, and one's just review. To be honest, I'm going to go ahead and just, some of you are going to try to write all this down, and that's really not the point. I'm going to do this, I'm going to do this, I'm going to do a swoopy swoop this. Oh, I don't like my line. Okay. Average rate of change is a question that you can answer, an application that you can solve with something you've known for a long time. Average rate of change is finding slope. For those of you that are sleeping. Average rate of change is slope. If we have time, we would give high fives around the room, but we don't. That would wake you up. Average rate of change, hang in there, means find the slope. Now, there's all this like technical stuff in the sense of technically cutting through a graph in a sense, and that's why it's called average rate of change, because you're just looking at two different times and don't really know how the motion is happening in between. That's kind of calculus-y. We'll leave it till later. But average rate of change just means find the slope. But what looks weird about this formula, guys? They use function notation. Oh my goodness, it's like it's a thing, and it is. Okay, function notation, it's a thing. But if you have f of x, and if they give you x1 and x2, can't you plug in to find y2 minus y1? Oh, that's going to make you work a little harder for it. That's going to make you work a little harder for it. So, average rate, write down a slope formula. I want to do a quick example. Average rate, write down a slope formula. We're going to do this two different ways real fast. With a graph and with just f of x. Okay? So for letter A, if I was using the graph to find average rate between -2 and -1, couldn't I go to -2 and find my x1, y1? Couldn't I go to -1 and find my x1, y1? y2 minus y1 all over x2 minus x1. Simplify and solve, you guys know that part. So what's weird if I don't have a graph? And if they just give me the function? So what if we're just using f of x? Oh, average rate equals. From my problem, do I know my x values? Yeah. So I could do 1 minus 0. That's easy. But if I didn't have a graph and I just had a function, stink. How do I find y values? What's going on at 1 minus what's going on at 0? But is that enough to simplify solve? What do we have to do to get those numbers? Plug it in to where? The function. So I would plug in 1 cubed minus 3, apologize, quick math is -2. 0 cubed minus 0 is 0. What do the ellipses mean? Keep going. So you can actually find slope even if you don't have total points, only if you have x's and a function, or you can use a graph. Okay. Last but not least. Woo. Wait. Have we done y-axis symmetry before? Oh, come on. You don't like it. We've done it. We've done y-axis symmetry. Guess what? There's a new word for it. Same thing, though. Have we done origin symmetry?
Yes.
Yep. Guess what? There's just a new word for it. And there's technically a new way of doing it as well. Kind of, sort of, maybe. But we've actually seen it before, because we plugged in -x for y-axis, and it ended up simplifying to be the same as the original. And we've plugged in -x before and figured out that it was, or got, the opposite y value. Now, if I were you guys, when you get to the even and odd, remember, even and odd is literally just two different names for symmetries we've already done. If I were you when you get there, go back to symmetries. What am I talking about? You have them in your notes. Use your old notes to help you out. And with that, we're at the end. Section 1.5 due on Tuesday. Come Tuesday with questions. Tuesday is our review. So try to figure out as many questions as you can over the weekend. Bye, guys. If you leave homework to Monday night, you're in trouble. Your brain doesn't remember so hot. No Spanish quiz.
Today.
If you have questions, come find me. Bye, guys.